but you can stick with force due to gravity, that's perfectly fine. So what is the direction of weight or force due to gravity?
Downward.
Yes, matter of fact, it defines the word down.
Mhm.
So there's a force acting down on this. Any other forces acting on it after it's left the hand?
Well, the force of it being thrown.
Yeah, the initial velocity.
So there's Jedi powers from a distance, he's able to influence it?
No.
No, he's throwing it. He's going.
Wouldn't there be other forces besides gravity that would affect it? You mean you haven't stated like wind or something?
Okay, so let's just go ahead and get rid of that one, no air resistance.
No.
There would be, but that makes it a lot more complicated. If you haven't watched the videos yet, lots of fun. I think I have it listed under the forces, chapter 5, but air resistance just makes this a bearable problem. So, but there would be, the air resistance would be in that direction right there. Go ahead.
Oh.
But we were going to,
No.
if you're looking for punishment, then go ahead and work the rest of the problem with that in there. The force from his hand is still influencing it only if he has Jedi powers.
Oh.
But we will assume that Jedi powers do not exist in classical physics, which is what this is.
Some of the Jedi powers. Kind of fun.
Unless someone, I'm sure all of us in here have tried at some point to do something with Jedi powers. I think that's a common human thing. Has anyone succeeded?
I went to the grocery store and I opened the door by myself.
Other than good. Okay, possibly. I don't want to discount. We will assume for this course that Jedi powers do not exist, that you do not have the power to continue to be pushing on something that you're not touching.
So, is inertia something we gotta worry about?
Not a force. Inertia is just the tendency of an object to keep doing whatever it's doing,
Oh.
and it requires a force in order to change that, whatever it's doing. So we've identified a force that's going to change its behavior. Otherwise, it would just go in a straight line at constant velocity. All right, that's it. That's the only force acting on it,
Oh.
because we're ignoring air resistance.
Are we ever gonna have air resistance in this class?
I tend to shy away from it. We probably don't have time to do it. If you can get your fix by watching the.
I don't have a fix, I was just hoping. for something.
Okay. The option's out there. All right, so there's only one force acting on it. What's the direction of that force?
Down.
Yeah.
That is the direction of the acceleration, down. The velocity, because we have velocity in two components here, there's a horizontal and a vertical piece to it. The horizontal component stays constant. It is not going to change at all. The vertical component will change because there's acceleration, therefore there's a change in velocity vertically. Now, the first projectile motion video, I go into a justification for doing this a little bit more detail. But we break this up into two problems. 2 dimensions, 2 problems. There's my vertical, and then horizontal. So what's my horizontal acceleration going to be?
0.
0. You got it.
Displacement. Vertically, my displacement, well, what is my vertical displacement in the end?
-20.
You want to throw some units in there?
Meters.
All right. Horizontally, that's what I'm trying to find. What's my horizontal displacement? I guess technically, let's not write 30 quite yet. it's gonna show back up in just a moment. I chose this angle and that initial speed for a reason. I need to figure out what my horizontal and vertical velocities are. This is breaking a vector up into its components.
Oh, yeah.
And so, whatever I'm breaking up is the hypotenuse of a triangle. So that's my 50. I've got a horizontal component and a vertical component, and this angle right here is 37 degrees above the horizontal. This is a right triangle, so I'm assuming everyone's right triangle trig is sufficient.
I wouldn't say sufficient.
Sokotoa? You got that down? Okay, that's sufficient.
Oh, okay.
Cool. I'm going to just label this A and B. So I know that the cosine of the angle is the adjacent divided by the hypotenuse. So A is just the hypotenuse times the cosine of 37 degrees. Which is 37 point something.
39.9.
Oh, yeah, duh. And then B is the opposite side, so that's gonna be the hypotenuse times the sine of the angle. And that should be around 30. I think 30.1 if you take it out that far,
Let me do that.
please.
39.9, 30.
And the other one was what?
30.09.
30.09 to 30.1, okay, meters per second. Occasionally on the test, I know 37 degrees is slightly off the 345 triangle, that's why we have those extra decimals there. Sometimes I'll just put the 36.8, whatever, like 10 decimal places for the angle, just so that it comes out better than this. But we'll stick with those. Now, I'm gonna round it off. So this is 30 meters per second, and this is 40 meters per second. Just to make the math simpler. I did establish up as positive. I haven't established a left or right positive or not, and I'm just gonna go ahead and establish to the right is positive.
Yay.
So I hat, J hat. My final velocities, we'll need to calculate. Well, actually, just to answer how far it goes, we don't, but what's gonna be my horizontal final velocity?
0. It stops, right?
Pardon?
What did it stop at the
Maybe
end?
40 meters per second?
Yes. You're stopping because you're assuming it hits the ground?
Yeah.
Once it hits the ground, it's no longer constant acceleration and things change.
Oh.
So what we're concerned with is, even though the language is, I think it was said before you walked in, even though the language is what's the final velocity, it's the velocity just before it touches the ground.
Oh, okay. That clarifies a couple of.
So 40 meters per second, because the acceleration horizontally is 0, there's no change. All right, so,
Sorry.
Yep.
I'm so sorry. Could you clarify why final velocity for horizontal is 40 meters?
the acceleration is 0, because the force acting is vertical. And because the acceleration is 0, acceleration is related to the change in velocity. If acceleration is 0, velocity doesn't change.
So it stays constant?
Yes.
So you just keep the yeah, okay, perfect.
Okay, that makes sense.
Creating your axes, the horizontal and vertical, or shouldn't do that. Creating I hat and J hat axes so that acceleration is 0 in one of those directions is something that we will be doing throughout the course. It is really convenient to have one of our accelerations to be 0. All right, solving for time. Now, earlier I said as long as you know three things, you can find the other two. This is an exception when the acceleration is 0, so we can't find time even though we know three things. But we do need to figure out time, because that is the glue that binds them. It is in the air horizontally the same amount of time that's in the air vertically. If they were not, I'm not even sure what that would look like. Even in quantum physics, I'm trying to think, is there one of those bizarre exceptions, and I can't even think of an exception. All right. Now that's so weird. Okay. So I'm trying to find time. I had 4 equations written up here, but I've erased them, but presumably you have them written down. What equation are we going to use to find time?
Is it the,
It's the VF squared equation.
We'll just use
Oh,
velocity.
you want to find final speed?
Oh, no, you're trying to find time?
I was trying to find time.
Oh, never mind.
could we use the change in the vector s? Is that what it is?
So delta S.
So equals the initial velocity times time plus 1/2 the acceleration times squared.
Okay.
If we can plug in those variables, maybe we can rearrange it to where we have t on one side.
Let's stick numbers in first. So what am I'm trying to figure out how long the thing is in the air. I can't figure it out with this information. Can I figure it out with this information?
Yes.
I hope so. I don't have any, acceleration is not 0, so, I do know 3 things. I should be able to figure out the other 2.
So -20 equals 30 times t plus half times -9.8 times t squared.
We'll go ahead and stick in the 1/2, -9.8. We now, again, have a quadratic equation. We solve for time. And for time, we get -0.6065 seconds and positive 6.972? 792.
729, or
What's the order?
729.
729.
Oh, we already saw it. No. I was trying to figure out how you guys did that.
Yeah.
I was like, what the heck?
We are just that brilliant.
I was blown away. Maybe I'm in the wrong class. You guys are way too smart.
I have done that on the test before, where I've given a problem and then, given another question which would have the exact same answer. And, if you're not thinking along those lines at that moment, then, you're potentially just reworking the problem all over again. All right. So obviously, only one of these has any physical meaning in terms of the context of the problem, and that's obviously the positive time. So we now know the time, 6.6, forgotten already, 6.729 seconds. It is the same over here.
Oh.
We can now find R. What equation?
Delta S equals the initial velocity plus the final velocity over 2 plus t.
Times T.
Oh, minus plus.
All right, so delta S equals VI plus VF over 2 times time. This is just average velocity for constant acceleration, or I'm just averaging initial and final. So that's 40 times time of 6.729. And somewhere around 300. No,
269.16.
Meters per second? Oh, no, but it's just length, so it's big meters.
Yes. Classic standard problem. In the lab, what you're gonna do is you'll initially fire the thing horizontally, so that your initial vertical velocity is 0. From that, if you know how far it's gonna drop and you know that it's being shot horizontally, so vertically, the time is, initial velocity is 0, you can find time easily enough. You don't have to use a quadratic, or you don't have to use the quadratic formula. You could if you wanted to, but I think you can solve it without it. And so once you know the time, you can then figure out, you'll know how far it's shot because you're shooting it horizontally, and you'll figure this out. Same equations, just slight different unknowns. So if that term dropped out, you can solve for time. Once you know time, you'll know delta S, you know time, you'll solve for the initial velocity. And then you're gonna shoot it up at an angle. And so you will make a prediction of how far it goes versus how far it actually went. So that is something that you'll do on Thursday. And then I throw in, and I think it's the last one where you'll be doing uncertainties. So, I'm sorry, that is the last one. But I do have a document there where I go through step by step an example problem of finding the uncertainties. All right, questions before I change it?
Do we have to find VF on the variable side?
We can. Now, somebody suggested finding VF first. We could have done that, and if we find VF initially, we could avoid using the quadratic. But if all I'm finding is time, I can do it with one equation, or I can find VF and then find time. It'll be 2 equations, no quadratic formula. It all depends upon, well, ultimately, how your mind is working at that moment that you need to do it. So let's find VF. What is the vertical VF?
I use the VI plus AT.
All right, so that's 30 plus negative 9.8 times 6.729.
And I got negative 35.9442 meters per second.
Which is what we had before.
Yeah.
And next question is one that has thrown many students. What's the final velocity?
In terms of vertical, is that what you're asking? Or in terms of both?
I want final, for the problem, I'm not breaking it up. I'm not asking for just part of it, I want, what is the final velocity?
50
I'd
meters
be,
per second.
Positive. Oh, sorry. Go ahead.
I heard several voices and then
I said 0. Not 0.
not 0.
I said 50 meters
Not,
per second.
yeah, no, not 50.
Yeah, we have to do, now that we have both the velocities for the final velocities, we gotta square them and then add them and then square root them, right? To get our final vector velocity. I'm
Okay,
gonna
you're gonna suggest?
Yeah, I would like, the Pythagorean theorem.
Alright, so let's go to that and let's see if we're doing it that way. If that's the right way to do it. So we've got down and to the right. So down is 35.9442, and to the right was 40.
So it's 40 meters per second to the right, the final velocity.
You said 40 meters per second to the right?
Yeah.
That would be not a complete answer. Or are you saying I miswrote something?
I don't know, I might be off.
Yeah. Hector, you look like you've done it.
I did it, I got a final velocity of 53.77 meters per second.
So you're saying the final velocity is 53.77 meters per second?
Yeah, it's way longer than that, but I just left it at that.
Yeah, round it off.
178.
So,
There you go.
I got it.
Sorry about that.
Is that the final velocity?
Is it, would it not just be 35.944?
It would not.
It's not, okay. Do you see where I got that from?
We could also write it like, with our hats. Like,
Do you want a direction? Is this why you're asking?
What is velocity?
Speed with a direction?
Yes. Do we have a
so
direction?
we don't have a direction.
If you answer 53.778 or 77 meters per second, you've told me the speed. That's the final speed. That's not the final velocity.
Okay.
This is a vocab thing.
So it
Say-
would be,
No, you go ahead.
okay.
I'm just spitballing.
Would it be 40 meters per second I had plus the 35.9442 J? That's Y, right?
What? That? That's.
Oh,
that's
I
a
did it
J
wrong.
hat.
Did I do
That's
it?
an I hat.
So I did have it. So 40 meters per second I hat plus 35.9442 J hat. Would that give us the direction? Because then we know that that's going
Alright.
in negative J direction.
Let's work on what you did as answer first, and then answer your question about whether that is the answer. All right, there were two mistakes in what you just said.
Oh, you want me to figure it out?
So it's opening up to everybody, but if you want to correct yourself.
How to solve it? Is that
All
what it
right, so what he said was the final velocity, 40 meters per second I hat plus 35.9442 J hat. That's what I heard you say.
Yeah, that is what I said.
You're missing the meters per second on the J hat.
All right, so units and, yeah, it's negative.
I did forget the meter, like it was there in my head, but I did not say it.
Okay,
And I get, okay, so the negative would just, okay.
yeah, and it's negative because it's going downwards, and I said positive.
Oh, okay.
This is acceptable as a final answer.
Oh.
This is rectangular form.
Could we also just put that in angle brackets, if that makes sense?
Oh, that?
Mhm.
Uh,
With the 0 for